Hello. In lesson 3, when we were talking about permutation, we said order matters. But in this new lesson, lesson 4, we are talking about combination. And in combination, order doesn't matter. Though the logic of selection kind of remains the same, but in combination, order doesn't matter. So for example, if I am told to choose 2 fruits from 3, I don't care how I arrange them, in which order, I just need to choose 2 fruits from the 3. So in this case, as opposed to using the formula for permutation, I'll use the formula for combination, which is given by C into brackets n, where n represents the total number of items I want to choose from, then R, where R represents the items I want to choose, is equals to n factorial over R factorial, then n minus R factorial, where this, of course, this n is the total number of items, then R is the items I want to choose from the total number of items. Let me show you here. So let's say if I have, I want to choose 2 fruits from 3 fruits, where I have an apple, a banana, and a cherry. I can do so by first combining or selecting in this format of apple and banana, but also I can select in this combination of apple and cherry, and then again I can also select in this one of banana and cherry. I don't care the order they come. I don't care about that order. All I care is just I've selected 2 from the 3 fruits. So instead of doing all these things manually, I can just choose the 2 fruits to represent R, and then n to be the total number of fruits, which were 3. So I come in my formula and say C n, which is 3, choose 2, is equals to n, but I already know n is 3, so 3 factorial over R factorial, but I already know how to factorial R is 2. So in n, which I already know is 3, minus R, which I already know is 2, then factorial. And then this becomes 3 factorial over 2 factorial into 3 minus 2 is 1, then 1 factorial. So it becomes 3 factorial over 2 factorial is 2 by 1, which is 2, by 1 factorial is also 1. Then it becomes 3 factorial is the same as 3 by 2 by 1 over 2 by 1 is 2. So this 2 goes with this, and then I remain with 3. So you see, I can choose 2 fruits from the 3 in 3 different ways. So can we try another example? Like for example this one, and the number of ways to choose 2 books from ABCD, meaning in no particular order. I just want to choose 2 books from the form books. So do so, I can do it like this. C n is the total number of books, which are 1, 2, 3, 4, which are 4, but I only want to choose 2. So it's given by n factorial over R factorial into n minus 1 and minus R factorial. So it becomes n, I don't know n is 4 factorial over R, but I don't know R is 2, so 2 factorial into 4 minus R factorial, minus R, which is 2, but now factorial. So this becomes 4 factorial over 2 factorial, then into 4 minus 2 is 2, but now 2 factorial. So this one is the same as saying 4 by 3 by 2, but instead of saying 2 by 1, can just say by 2 factorial over 2 factorial, then multiply again by 2 factorial. But since I have a 2 factorial here and a 2 factorial, I can cancel 1, then I remain with 4 by 3, which is 12, then over 2 factorial is 2 by 1, which is 2. So it becomes 12 divided by 2, which is 6. So can we try the last example and we see, so if I have, somebody ask me, how many ways can a team of 3 students be selected from 5 students? So you see here, we don't care about the order we select them. We just need 3 from the 5 students. So in that case, then n becomes 5, which is the total number of students, and then r becomes the number of students we want to select from the total number, which is 5. So if I apply now C, it will be C5, 3 is equals to n factorial into r factorial into n minus r over now factorial. So I already know n, which is 5 factorial all over r factorial is r is 3, so 3 factorial into n minus r, which is 5 minus 3, so 2 factorial. So it will be 5 factorial into 3 factorial, then by 2 factorial, which becomes 5 by 4. And then since I have a 3 factorial, I can just put a 3 factorial here too. Then I divide by 3 factorial, then 2 factorial, which becomes this 3 factorial goes with this 3 factorial. I remain with 5 by 4, then divided by 2 factorial, which is 2. 2 factorial is 2 by 1, which is 2. So it becomes 5 by 4, which is 20, divided by 2, which is 10. So I can choose 3 out of 5 students in 10 different ways if order is not an issue, if I don't want them to be ordered. So the key points I want you to remember here is, in combination, order is not important. In permutation, order is important. So most of the time, it's kind of like combination is a bit easier than permutation, because in combination we don't need order, but in permutation we do. So let's meet in the next lesson. Bye for now.